out candy. My son was a minion. It was so cute. Oh, that sounds intense, Mia. I've never seen that before. Ooh, a concert? What concert, Adrina? Ooh, okay. I've never heard of them, but that sounds like fun. All right. Well, let's go ahead and get started today with our lesson. So we are starting a new unit today, Unit 5. Yes, I am, Sky. Live. Oh, that's so cute. Oscar the Grouch. That's very funny. Yes, Sky, I am. I am not at my house currently. So we are in a new location. No worries, Anya. Okay, so we're starting Unit 5, and this is going to be the last unit that we do before y'all get to be done for the semester. So, Unit 5, we are going to have a test in Unit 5 at the end, and then we are also going to have like a short little one more assignment, like writing assignment kind of thing in Class Kick. And then otherwise you are done. So that is like a good feeling after we get through Unit 5. Okay, so I know some of you are probably feeling a little worn out, but I just want you to know the end is near. We're already in November, if you can even believe that. And actually, once we get to Thanksgiving, when we get back from Thanksgiving, we have a review. It's not for a grade, but just a review, and then your Unit 5 test and your writing assignment. So really, if you can just make it to Thanksgiving and hold on, then we're going to be good to go. So you're not going to have any homework December 5th through 9th or the 12th through 16th. So you're going to have 2 weeks at the end of the semester to get caught up, make any adjustments that you want to. Okay, so hang in there. We're almost through. This is the last unit for this semester. So you started lesson 5.01 yesterday in your course. And today you should be doing 5.02. So we're going to try to cover both of those today. Well, Sapphire, happy very early birthday. I'll try to remember. Okay, so let's go ahead and get started. We're working on systems of equations. So we've been doing linear equations since Unit 3, okay? A system of linear equations. Oh, that's weird, Laura. Okay, let me check on that. A system of linear equations is when you're going to have two or more linear equations that you graph on the same plane. Okay, so, and we're going to work first on how to write systems of linear equations, okay, using two variables. So here's some steps. What we're going to work on today is simply steps 1 through 3. Okay, so we're going to work on steps 1 through 3 today. We are going to work on steps 4, 5, and 6. That'll be at the end of the week. Okay. Okay, see you in a little. Today, we're simply just going to read through some word problems. I know word problems are everyone's absolute favorite. We're going to read through some word problems. We're going to write an equation that represents that specific word problem. And that's all we're going to do for 5.01. Okay, so let's read through these steps before we get started. Step 1, read your problem, okay, several times if you need to, until you understand what information you're given and what information you are looking for, or what information is to be found. So we're going to read through it. Then we're going to go to step 2, which is assign variables to represent the unknown values. If we need to use diagrams or tables, we can, and we're going to write down what each variable represents. And then the last step is we're going to actually write that system of equation that relates the unknowns or our variables. So let me show you what this looks like. I'm going to cover some of this up. All right, so step 1 is read our problem. Okay. So a lot of these, when we're talking about systems of equations and we're actually writing out the equations, these are like real world problems. Okay, so example number 1, we're going to work on finding dimensions. This one is of a parking lot. Sometimes it's like a garden or a room. So let's work on this one first. We've got the length of a rectangular parking lot is 20 feet more than 3 times its width. I know these sound so confusing, but I think after today, you're going to realize it's not as bad as you think. The perimeter of the parking lot is 800 feet. What are the dimensions of the parking lot? Okay, let's read it again. We're going to highlight some important information. So we know that the length of a parking lot is 20 feet more than 3 times the width. Okay, that's a lot of information. We're going to break it down in just a second. Mia, you're close. These are actually, so remember with systems of equations, we have 2 different situations going on. So we're going to have 2 equations. So the first sentence deals with our first equation. Okay. It tells us the length and the width. It doesn't necessarily tell us exactly what it is, but it does tell us what the length and the width are. The second tells us about the perimeter. The perimeter is 800. Remember that perimeter is when you add all of the sides together. So if I add length, length, width, width, both lengths, both widths, I get 800. So length times width times height is actually volume, and length times width is area. So not quite, Mia, because if we just did 800 divided by 4, I like where you're thinking. 800 divided by 4 means all sides are equal, which would mean this was a square parking lot, but we have a rectangle. So we are finding, step 1 was read the problem. What are we trying to find? We're trying to find the dimensions. So we want to know, what does L equal? Okay, and what does width equal? That's what we're trying to find out. And we're going to find out, like, eventually the numbers. Okay, but we're not solving it today. So assign variables. Okay, we're going to let L equal length, W equal width. This is just like a little picture for you. So here's our parking lot. We've got length and we've got width. All right, here's where we get into writing it out. So step 3, write the equation. Okay, so because the perimeter, we know the perimeter is 800 feet, we can find our first equation using the perimeter formula. The perimeter formula is 2L plus 2W equals perimeter. Since we know the perimeter was 800, instead of putting it equal to P or perimeter, we set it equal to 800. Okay. And you have I think you have the formula for perimeter on your star sheet. So Liv, you're close. Here's the thing though. 200, 200, 200, 200. If all sides are the same, That makes it a square, but we know this is a rectangle. So it's not quite as simple. But let's read this next sentence. The length, so L, this is how we would write this. L, oops, let me do it in black. L equals, L is 20 feet more. So we're going to add 20 to something. To what? 3 times the width. So 3 times W. The length equals, length is, so length goes to L, is equals 20 more. That becomes plus 20. 3 times the width, 3 times W. And once we do that, actually, let me just make this a little bit smaller. Okay, these are now, let me highlight them in green. These are our two equations. 2 times the length plus 2 times the width equals 800. And length equals 3 times W plus 20. That's all we are doing for today. Later in the week, we will start going over how to solve this. But for today, for today in this lesson, exactly, Jonathan, all you are doing is writing out the equations. That is it. Okay? That's all you're doing for today. We are just writing equations. All right, I want to try another one. So let's check out another situation that we might have. All right, so let's talk about how to solve or how to write equations when we have prices involved. So let's read our problem. At a local restaurant, the price of 1 soft drink and 2 hamburgers is $12.15. The price of 5 soft drinks and 4 hamburgers is $32.25. Okay, so let's go over some important stuff. We have 2 situations going on. We have 1 soft drink and 2 hamburgers, $12.15. Then we've got 5 soft drinks and 4 hamburgers, $32.25. So we want to find out, what is the cost of 1 hamburger? What is the cost of 1 drink? So that's what we're trying to find. There are 2 unknowns. Okay, we don't know how much the hamburger is, and we don't know how much the soft drink is. So step 2 is we're going to assign variables. So we're going to say that S equals a soft drink, and H is going to be the price of 1 hamburger. Okay, those are the 2 variables we're going to use. So let's go through our first situation, which is 1 soft drink. So look at our first sentence. 1 soft drink plus 2 hamburgers. Okay, remember we said that the soft drink was going to be S, hamburgers is H. So if I have 1 soft drink, that's 1 S, plus 2 H, 2 hamburgers, it's going to equal $12.15. There's not going to be 3 variables because we're not worried about taxes. Okay, so now let's kind of do this one together. That was the first situation. So let's read that second sentence. We have the cost of 5 soft drinks and 4 hamburgers. So what is that equation going to look like? So we've got 5 soft drinks. So 5S. What's going to come next? Plus the cost of 4 hamburgers, 4H, is going to equal 32.25. Exactly. And that's it. That's our system of equations. That's all we are doing today is just working on writing the system of equations. Okay, let's see if we can do this next one if you're getting the hang of it. Maybe where am I? Okay. Questions. Oh, wait, hold on. I think I've got one more. Okay, so what if there are 3 variables? Let's go ahead and read this one. At a local bakery, a loaf of honey wheat bread, so we've got honey wheat, costs $2.69. A loaf of sunflower costs $2.89, and a loaf of French bread costs $3.39. On a recent day, twice as many loaves of sunflower bread were sold as honey wheat. So you've got, let's say you had 1 honey wheat, then twice as many would be 2 sunflowers. Okay. The number of loaves of French bread sold was 3 less than. So we have to put -3 at the end. 3 less than. Hold on, let me highlight these real quick. So we've got twice as many, and we've got 3 less than. The total amount of money for these breads was $96.58. How many loaves of bread of each type were sold? Okay. So we've got to assign variables. So we're going to let X be honey wheat bread, Y be sunflower bread, and Z is going to be French bread. All right, so now, why is this not going? Okay, here we go. We know that in our first situation here, let's take a look at this one. The first sentence says, twice as many loaves of sunflower were sold as honey wheat. So sunflower is Y. So Y equals 2 times the amount of honey wheat. Okay, Y equals 2X. Or if you wanted to set equal to 0, you could, but I would not. So you don't need to worry about this one. Okay, let's read the next sentence. The number of loaves of French bread, so French bread is Z, so Z equals 3 less than the number of loaves of sunflower. So sunflower is Y, so Y minus 3. That's our second equation. Let's read the next sentence. The total receipts for each of these breads was $96.58. Okay, so we need to add up all of the bread with their prices, okay, because this is talking about money. So we're going to say, okay, we've got honey wheat. Oh, how much did honey wheat cost? $2.69. So 2.69 times the honey wheat plus $2.89 for sunflower, and sunflower is Y, plus $3.39 times Z for French bread, and that's all going to equal $96.58. Okay, so basically, what we're doing is in writing the sentences that we are given in words, we're writing it as an okay. asking you to solve none of that, okay? It just wants you to write out. That's all we're asking you to do at the start, is just to write out the system of equations. In your homework, you are only going to do like two equations. Okay, so you won't have any that are three, just two. Okay, so now we're going to talk about your assignment that is going to be due today. It's in 5.02. It's the 5.02 homework. And since we have this, when we write systems of equations, it's an equation of a line. Okay, so don't forget that. We're writing a system here. We're writing an equation, and the equation is a line. So one of the ways that we can solve systems of equations is to graph them. So what we're going to talk about now is graphing these systems of equations. So since it's a system, they're both going to be on the same coordinate plane. We've got 3 steps to graphing systems of equations. Step 1 is to graph both your equations. Okay, so you're going to get your equations into y-intercept form, and then you're going to graph them. Step 2 is you're going to look at your graphs and figure out, okay, do these graphs intersect? If they intersect, that is your solution. We're going to write our solutions as an x, y coordinate, and then we can check our solutions at the end. What you do for that is you plug in your solution, whatever your solution is, plug in a number for x, plug in the number for y, and then it should equal itself. So let me show you what your 3 options are. When you graph a system of equations, you will get one of these 3 options. You will get either intersecting lines, parallel lines, or the same line graphed on top of itself. If you get intersecting lines, this means there is one solution. The solution is where they intersect. Okay? So there's one solution. If you think about it, that makes sense, right? We can't have 2 solutions or more than one solution for linear because they're straight lines. So for them to come back and intersect again, they would have to curve. Okay, so we're either going to have one solution, which is where they intersect once, or we could have no solution when the lines are parallel. So if they have the same slope, that's how we know if lines are parallel. If they have the same slope, that means they're parallel to each other, and we know that parallel lines never intersect. So you could have no solution. Or it could be the same line graphed on top of itself, which means every point on the line is a solution, and therefore there's infinitely many solutions. Okay, I'm going to give you a hint. These next boxes are on your homework for 5.02, so please pay attention because I'm giving you the answers here for you to just go fill out. Okay, so let's go ahead and read this first statement. It says, if 2 lines have the same slope and different y-intercepts, then the lines are, well, we just talked about that. If they have the same slope but a different y-intercept, then the lines themselves are parallel. And we know that parallel lines do not intersect. So therefore, they have no solutions. A solution is where the lines cross. All right, statement 2. If one equation can be obtained from another equation by multiplying both sides by the same non-zero number, basically meaning they are the same, then this system has infinitely many solutions. Okay. Infinitely many solutions. An infinite number of solutions. Alrighty, let's take a look at the next one. If two lines have different slopes and the same y-intercept, so they are different slopes, but they both cross the y-intercept at the same point, that is the solution. Okay, so then those two lines are intersecting. And they would only have one solution. And then lastly, if two lines are parallel, the system has no solutions. So, Angel, you should be able to do everything in the Desmos star calculator that you can in the TI-84. But if you want to send me an email with what you're talking about, I can look into it. Okay, so let's go ahead and see how we use this or what we do. So we're going to be given a system of equations here. Okay. So for the homework, there's only, well, for 5.01, I think there's 5. So you're going to just do 5. Some of them only have 5 problems. So in that case, it would be everything, but you're going to still just do 5. All right, so what we need to do is check and see, are these in slope-intercept form, meaning is y by itself? Yes, it is. So then what I'm going to do is go ahead and graph. I'm going to graph this first one in blue. So I graph my y-intercept first at -3. Then I'm going to go up 2 and to the right 1 because that's my slope. Up 2, right 1. And you may have to graph a couple points because we have to figure out where they intersect. Okay, so you may have to graph more than just 2 points on your line. All right, now I'm going to graph this bottom one here in red. This y-intercept is at +2, and the slope is -3. So that would be down 3, 1, 2, 3, into the right 1, and there's the point where I intersect. Okay, so since these lines intersect, there's going to be one solution, and I'm going to write the ordered pair for that solution. So the x value is +1, the y value is -1. So this is the solution to this system of equations. What this means is that if I plug in 1 for x and -1 over here for y, that's going to give me a true statement for both of these equations. Okay. Okay. What if our equations are not in slope-intercept form? Well, then we have to put them in slope-intercept form. So let's go ahead. I'll do this top one in blue. So let's go ahead and solve for y. So we've got 2, oops, why is that not writing? 2, here we go. 2x plus y. Man, why is this pen being goofy? Oh, man, that's ugly. Okay, let's try again. 2x plus y equals -4. Remember that I want to get y by itself. So I'm going to subtract 2x from both sides. And then I get y equals -2x minus 4. That's my first equation. So I'm going to go ahead and graph that equation on my coordinate plane. So at -4, I'm going to put my y-intercept, my point. This slope is like a -2 over 1. So I could go up 2 and to the left 1. Okay, and draw my line. There's my first line. Any questions about how I solved for y or graphed that before I keep going? Okay. Then let's go ahead and solve the next one for y. So we've got x plus 4y equals 12. Again, I'm solving for y, so I'm going to subtract x from both sides. I get 4 times y equals negative x plus 12. I'm going to pause there, so if anyone has questions, let me know. If you're not sure how I got there, let me know. All right, I think, are we good or? Okay, so let's go ahead and divide everything by 4. I would get y equals negative 1/4 x plus 3. So we're going to go ahead and graph this one as well. So we start by graphing our y-intercept first, which is at positive 3. And then I'm going to go down 1 to the, let's see, right 4. And then I'm going to go up 1 and to the left 4. And there is our intersecting point. So this point here is our solution, and we would write it as an ordered pair. So we say, okay, what's the x value? That's at negative 4. What's the y value? It's at positive 4. And that is our solution. Okay. So what I want to do right now is give you time. You can log into ClassKick. If you've already done 5.01 homework, that's great. Start working on 5.02. If you have not done 5.1, go ahead and work on that one. Or you can work on this one. Whichever one you want to do first is fine. But I want to give you 10 minutes to work and while I'm in here. So that way, if you have questions or you're not sure what you're supposed to be doing, you can ask me while you work on your homework. Ben, that's a good question. So if you have a curved function, and it's a system, it just depends. Like if it's 2 curved functions or a parabola and a linear function, it really all just kind of depends. But you'll get into that maybe in Algebra 2 if it's still important. Sometimes it's really not, I don't want to say it doesn't matter, but you're not going to use it. So we don't always cover things that you're not going to use. RJ, I just went over graphing systems of equations. So if you want to take a look at 5.02 homework and let me know if you have any questions, that would kind of be what you missed. But otherwise, I think you're good. Yeah, those questions that we just did, the 2 problems, those are actually 2 problems straight from the 5.02 homework. Yep. So I mean, you still have to show your own work. But yeah, I actually pulled those right from the homework just to help y'all out a little. Does anybody have any questions? Well, good, Angel. I'm glad you think that. Angel, yeah, if you just have one that you want me to look at, tell me what number and what homework you're on, and I can check on it. So, Ben, linear equations, that's a good question. Like you're asking about, linear equations are in the form y equals m times x plus b. So x just has an exponent of 1. We in the second semester will start going over when we have x squared. So if the exponent above x is not 1, it could be 2, 3, 4, 5, 6, whatever. That's when it starts to curve. Angel, yeah, you can use any variables unless it tells you specifically what variable to use, but I think for the most part you can use any variable. So point slope is still just the form of a linear function. Angel, you can use whatever variables you want. That's totally fine. All right, we've got about 5 minutes left. Does anyone have any questions for me so far, or any ones that you want me to check? I would be happy to do so. Okay, Ben, let's read your question. Well, for those specific ones, yes, it would intersect into, but that's not always the case. But yes. And you can solve, like, let's say you're given this problem like on the STAR test, and it just gives you like this system of equations here, and you get it in y-intercept form. You can graph it on your calculator and look at the solution. You don't have to graph it by hand. I just want to see you graph it by hand for this first one for 5.02 because I want to make sure that you know what you're doing. And yes, Ben, that would be 2 solutions. That's exactly right. Sometimes, yes, Ben, sometimes. Okay, so Anya, good question. The interim for this class, I believe it opens on the 7th, so next Monday. But that's November. So next Monday. The December 6th through 9th says STAR EOC retest. So that is for anyone that has already taken the Algebra 1 STAR before and did not pass it. So it's just a retest. If this is your first time taking algebra, your STAR test is not until May. But if you've already taken the STAR test once and did not pass, those are the people. Okay, perfect. So those are the people that will be retaking it. Okay, Adrena, what's your question for 5.01? I can go to it. Yeah, no, we've only gone through half of the material, so it is okay. Good question. All right, Adrena, I'm pulling up 5.1. Oh, okay, so 18 more than. That's a good question. Let's take a look. All right, so it says the sum of two numbers is 84. Okay, so you did perfect. N plus O, you did number and other number, great, equals 84. One number is 18 more than the other numbers. So you're going to do, let me go back to my, let me do a whiteboard here. All right, so I'm going to use, for simplicity's sake, I'm just going to say one number is X, one number is Y. Okay, so it said that the sum of two numbers, so sum means I added them. So X plus Y equals 84. Okay, great. Then it says one number is 18 more than. So X is going to be 18 more than. So X plus 18 would equal Y. Right? So if we have Y, or sorry, if we have X, and we add 18 more to it, it's going to give us this new number. Ben, you could probably go pretty high. Good question, Adrena. No, so for 5.1, they should all just be writing the system of the equations. It just says write a system of equations. No, because it's not going to be N plus 18 equals 84. It'll be N plus 18 equals O, because your numbers are, you did N and O, right? So N plus O is what equals 84. But for the second equation, we're just trying to figure out what does O equal. So the other number is the number N plus 18. So these would be your two equations. And that's an O. I would probably use, you can leave it as O for right now. Sometimes O's look like zeros, so that can be confusing for people, but that's fine for now. I'll understand what you mean. Ben, I don't think so. What was your TFAR email? You guys are free to go